Hello and welcome to my C++ video 2 tutorial. My name is Dan McFinsky. I'm going to try and go over some basic things here in this tutorial and kind of build off of the last tutorial in which I described how to make a basic C++ program or a basic C++ console program. So in this tutorial I'm going to make another C++ console program, only I'm going to try and illustrate how to use integers, characters, floats, doubles, all different variable data types to create an interactive console program. I'm also going to explain the cin operator and cover a little bit of math, and then try and describe how you can go about using Visual Studio to fix errors in your programming. So as usual, I'll start off with a new project. Again, Control-Shift-N. And I highly recommend using the keyboard shortcuts as best you can. So I'm going to call this Intro to Variables. And I'm going to go ahead and put this in my Intro to C++ directory. And I'll make sure that Windows 32 console application is selected in this dialog. Hit OK. And as usual, I want to hit Next in the next dialog box that pops up. And I want to make sure that I'm creating an empty project. Then I can hit Finish, and Visual Studio goes ahead and creates my solution and my project. Okay, so as I explained in the last tutorial, the best way to add files is just to right-click and go to Add a new item. And again, there's a keyboard shortcut for that. That's Control-Shift-A. I'm going to go ahead and use Control-Shift-A. It's going to ask me what kind of item I want to add. In this case, I want to add a C++ file. So, and then it wants you to give it a name, Intro to Variables. I'll go ahead and uppercase the 2. Okay, so it creates a new file, Intro to Variables, under the source files directory, and then it also opens up the source file for me to start writing my code. So in the last tutorial, I explained how to include libraries. Again, we're going to do the same thing in this tutorial, and you're going to find that just about every single file you create, you include a library of some sort. So just get used to including them, and eventually as you use them more and more often, you'll start understanding exactly what they are and why you're doing this. Again, using namespace makes the std namespace, which encapsulates everything in the IO stream, available globally to your program. So that's extremely important. And then we have our entry point for our program, which is our main function. So again, a function is a set of instructions encapsulated by a name, usually with some kind of return value, although you don't have to return something. In the main function, you can write this program without returning anything. You can also declare functions that don't return anything using the void keyword. But in this case, main is supposed to return an integer, and just because I like doing what is supposed to happen, I'm going to go ahead and issue a return 0. Of course, you don't have to return this. Nothing bad will happen. Windows understands that if a program doesn't return anything, that it just finished without an error, or at least I think that's how it understands it. But that's not really important for these small console applications right now. So anyway, so now we have our main function. We have a functioning program here. I can compile this and I can see what happens. And you can see nothing actually happens, but it compiles. It doesn't give me any errors. So now what I want to do is I want to go over different data types. So there's what's called an integer. This would be equivalent to a number. This is basically a data type that stores the contents of a number in memory. So your computer has a bunch of RAM, and every time you declare something like an integer and give it a name, your computer basically says, all right, let me save, or let me get, or what's called allocating, let me get this amount of RAM space available, and then you can store whatever number you want in that space. So another great thing to know is comments. So here I'm going to use comment. You can put a comment anywhere basically, as long as you preface it with the double /, or you can do a / and an asterisk, and then to close that comment, another asterisk and then a forward slash. Anything between this is a comment. This is a comment. This is an integer variable. Or you could say this is a variable of the integer data type. So these are just two different ways to comment. I'm going to leave these on the screen so you can look at them. But so this way of commenting is extremely useful. Actually, both methods of commenting are extremely useful. This one is if you want to write a block comment, so you have a paragraph of information that you want to write. Often this is used before a function name, so you can use it here. This is the main function, which is the entry point for this program. You can see how I can just keep typing there. Whereas with this comment style, the next line is now a new line. If I start typing, this is still a comment. You can see that Visual Studio thinks that this is an instruction for C++, and it gives me all sorts of errors. So I'm going to go ahead and cancel that there. So now I've declared an integer variable called number. So what I've done here is I've told Windows that I need some memory space to store a number. And now number can be filled with any kind of number. There's 150. So number now has the value 150 stored in it. Store 150 in number variable. So you can see I can comment every single line if I want. And this would help me in the future if I come back to this program and say, all right, what does line 14 do? And then I can read that. What does line 15 do? And then I can read. So comments are extremely useful in that sense. And I highly recommend using comments as much as you can, especially when you're first starting out, so that you can help yourself remember things. And it helps kind of drill the points home. I'm going to go ahead and erase this now. I'll add a comment here, integer variables. Now I'll add one here. Here, let's say we're going to go over char, all these character variables. So now this is a new variable type called a char, or character. This declares a char variable. Now a char basically, character equals, basically this stores a character of any kind that's in the ASCII character map. So I can store a character A, for example, and the characters are always denoted by single quotes. Alternatively, I can store any letter of the alphabet, A, B, C, but I can only store one. I can store any number because a number is a character. I can store any symbol because, again, symbol is a character. These are all characters that are part of the ASCII character set. And one way to learn what kinds of characters you can store, you can bring up Google, type in ASCII character map, and you can see here there's a character map that shows you all of the different characters that are in the ASCII character set. And they're all denoted by first a decimal number, a hex, an octa, an HTML definition, and then a character definition. So the character is what you see visually. And in some of these cases, the earlier characters are escape codes. You can see the description here. This is the start of a heading. The zero is a null. Those things you definitely don't see, but they're actually registered somewhere, and you can actually store them in C++ as characters. So an example would be, and this one's really common, the /n. This character is used for a new line. So you can store all sorts of things. So I'll go ahead and put A there. And also you can see how back here each character has an equivalent decimal number. So that means that in C++, the character A, the lowercase a, would also be equivalent to this number 97. So that becomes useful in the future, and I'll go over that later. So store a in character variable. So other data types I can store, and these are called fundamental data types because they come as part of C++, and you can use them without requiring any additional libraries. They're base data types. So a double is another data type, double variable. So a double number. And you can also just issue, instead of just declaring the variable as I've done here, you can declare the variable and assign it to a number or to whatever data type it is right off the bat. So in this case, I've said I'm going to create a double variable type called double number, and I'm going to assign it to this number 1.434, etc. The double basically is a variable, or is a data type that stores highly precise floating point numbers or highly precise decimal numbers. Then there's a float data type, which stores less precise float number. It stores less precise decimal numbers. So you can see I've created all these different data types. Again, I highly recommend commenting. This declares and stores a double data type variable. This declares and stores a float data type variable. There we go. So now I can go ahead and compile this, and it should run just fine, but of course I'm going to hit Control F5 to compile it, and of course nothing's displayed on the screen, and that's because we don't have any output commands here. Even though I've included the IO stream, which allows me to get input and send output to the screen, I haven't issued any commands that output anything. Now, if I wanted to, before outputting anything, if I wanted to see what was inside of any of these variables, I could start adding breakpoints, and then I could just hit F5 or debug and just start debugging. If I hit F5, I've added this breakpoint on line 17, which means that anything before line 17 that has already been executed, I should be able to see the values that are stored in the different variables. So in this case, int number was declared on line 12, and then on line 13 number was assigned to 150. So if I roll over number, you can see it says number equals 150. And also down here in the autos tab, you can see number equals 150. So that's great. But if I look at character, character has this weird symbol in it because I've defined it, but I haven't assigned it to anything yet. So basically it's pointing to some memory space that has something in it, which is this weird symbol. But it hasn't been assigned the variable that I want, or the data that I want, which is the lowercase a. So I can add another breakpoint, and I can hit F5, or I can go to continue up here, which is also available on your toolbar here. There's continue. I recommend using F5, and that'll drop down to the next line, which means that line 17 has now been executed, and I can see character now equals a. And I can also see it down here in the autos. Character equals a. And if I roll over my number, you can see that number still has the value 150. So by adding these breakpoints, I can see each line and see the result of what's happening there. This double number is extremely precise and has lots of zeros at the end here, which is going to be a lot more precise than my float. So currently my float has some weird number in it because it hasn't actually been executed yet. So once I hit F5 now, you can see my number is this 1.234 with 4 zeros at the end. My double has, I don't know how many zeros there are, hard for me to count off the bat, but it has a lot more zeros. So you can kind of see the difference between the double and the float there. But now that I've defined these variables, I can do things with them. So I'm going to get rid of these breakpoints here. and I can start doing things with them. So let's say I want to output each one of these variables. I'm going to output my number. So I can do cout and then the stream insertion operator, and then in quotes my number is, and then another insertion operator, number, and then I'll go ahead and hit end L after insertion operator, and this will add a new line. So what I'm expecting to see here is the text my number is, and then 150 followed by a new line. So I'll go ahead and hit Control F5 because I don't have any breakpoints here and there's no way for my program to stop. So I'll hit Control F5 so that Visual Studio automatically stops my program for me. So Control F5, and it says my number is 150, and then press any key to continue. Alright, so that's exactly what I expected. So I can do the same with all of the rest here. Output my character. So I can say cout my character is, and you can type in whatever you want here. The text isn't really important. What is important is that you refer to your variable names exactly as they're written. So if there's an uppercase or a lowercase, that's important. Okay, so I'm outputting character and then end L. So again, we should see the text my character is, and then a lowercase a. So go ahead and hit Control F5. And now you see my number is 150, my character is A. So that's great, exactly what we expected. Now we'll do the same thing with the last two here. Output my double. Cout my double is, and remember the stream insertion operators, double number. And always remember the new line, otherwise your text can get, your output can get kind of unwieldy. So my float, cout my float is my float number. We'll add a new line there, and so Control F5. And there we go. My character number, my number is 150, my character is A, my double is 1.43456, my float is 1.234, and then press any key to continue. Fantastic. That's exactly what we expected. So now there's other things you can do here. Now that you have some variables defined, one of the things you can do here is you can perform some mathematical operations. And I'll just cover this briefly, and then I'll do more in-depth mathematics in the next tutorial. So real quick, I can create a new integer. We'll define it by int, and I'll say the product equals, and I'll say number times 2. And so now I'll have a new number here stored in product, which is of an integer data type, and it equals my number, which I've defined up here as 150 times 2. So what we should get is this should equal 300. So I'll go ahead and output that. The product of 2 times, or I'll say 100, the product of number times 2 equals, and then product, and add a new line. So Control F5 to run that. And you can see here the product of 150 times 2 is 300. Okay, so that's pretty dry there. Just real quick before I end this, I'm going to try and explain an easy way to go over how to fix things if you run into errors compiling. Say you decide to hit Control F5 here, and I've just created a couple of errors. Of course, I know what the errors are going to be because I created them, but what's important here is that you see in your output window, you see it says build 0 succeeded, 1 failed. So once you see that, you can go to your window. Well, let's see, it disappeared on me there. View, you can go to your view and go to your errors. And that should be under here, error list, Control E. So you want to make sure to add your error list to the bottom here. And so in the error list window pane, you can see your warnings. Generally, you don't really want to see those off the bat, but you can see your errors. And again, that's Control E, or you can go to View, Other Windows, and Error List. I'm sorry, it's not Control E, it's just E, or Control \. So once you have this error window pane up and you can see your 5 errors, in this case you see 5 errors, although we really only have 2 errors, you can double click on an error and it takes you to the line up here. So if I was up here for some reason and I double click here, you can see it takes me to line 16 and adds this little dash. So, and then it underlines this stream insertion operator. And so it gives me basically an idea of where my error is. If I read further here, it says binary insertion, no operator found, which takes a right-hand operand of type overloaded function. There's no acceptable conversion. So some of that, or a lot of that, probably doesn't make much sense to anybody, or to at least people who are new to this. But basically, it's saying whatever's on the right side of this endl doesn't make any sense. It can't compute that. So I know already that it's supposed to be endl. So I can just add the L there, and that disappears. Now, when I have a list of different errors, and I'm not sure where they all are, I can hit F5 again and get it to compile and see it says failed again, and come back here to my errors pane and click on the next thing that's missing. And so I've clicked on the next thing, and it's taking me down to line 39. If you have a bigger window, it should automatically scroll the window pane, and you should be able to see it. But it's taking me to line 39, and so it's telling me that there's something wrong with 39. It says syntax error, missing the semicolon before string. So I can look here and I can see that something's missing. It says there's a semicolon missing, but that's not quite right. But if I examine this line, now that I know where the error is, I can see that there's a stream insertion operator missing right here. So I can just go ahead and add that back. But the general idea here that I want you to get is that it's easy to feel overwhelmed by that error list. There were a lot more errors than there actually were in my file. But what you should do is you should approach it by attacking the first error on the top and then recompiling. And that way it'll get rid of all of the errors that are associated with whatever the first error is. And then you approach the next error as it comes up. But always work with the errors at the top and try and recompile right after you've done that. And that way you will fix, if there's 10 errors, it's possible that there's only 2 or 3 real errors. And each time you fix them, it gets rid of 3 errors on the error list. So you won't spend time trying to solve each error, which may not necessarily be related, or may not necessarily make sense. So anyways, I'm going to go ahead and leave it there. So in my next tutorial, I'll try and go over a little more of the math functions, or a little more of the math operations that you can do, and also go over the cin function, which allows you to take in data from the console window. All right, I hope this was useful, and I'll see you in the next tutorial.